Hey guys and girls, we are back talking about energy transformation. We're talking about pie charts and representing how much energy that we have. We are going to be looking at this example of a rolling ball as it's coming to a stop. So again, the three pictures we have here, A, B, and C, are going to represent, again, that nanosecond of what is going on at the particular time. And again, just to refresh our memories, we went over different types of energy. Okay, I'm just dragging that out. And we see that we have gravitational potential energy that we're representing with, the color blue, and I just drew on there. Okay, so we're representing this with the color blue. Okay, kinetic energy we're representing with red. And elastic potential energy we're representing with green. And today we're going to be talking about dissipated energy, and at this time we're doing dissipated energy with respect to friction. We also know that dissipated energy also can exist when light is given off or heat is given off. So we're going to be looking at that specifically with this example. So I'm just going to drag this down a little bit. And I guess I need to take these little pictures away since they didn't go along with my pictures here. And now what we're going to be looking at is this example of rolling ball. So it's moving, which represents our energy of movement. So when we look at this, we're seeing that the ball is moving. So we're going to represent that with 100% of this kinetic energy. So I'm going to take red and we're going to color it in. Okay, and again, I wish when I was in kindergarten I really practiced how to color within the lines. But I guess you guys kind of understand what we're doing here. We're making sure that this is all red because it's all motion. So in this next instance, when we're looking at B, we're looking at the fact that, okay, so it's slowed down by half of the speed that it started with. But the thing we need to focus in on is this term that's here, dissipated energy. So we're going to be including two types of energy. We're going to be including our kinetic energy, and we're going to be including our dissipated energy that we have here. Okay, so as I said, it's half the speed. So what we're going to do for this particular pie chart is, hopefully, you filled in that you had half of this energy. Now the dissipated energy would then come into play by covering the other part. Okay? So again, we're assuming a couple things, that if the speed is cut in half, then the energy is going to be in half. So the dissipated energy covers that part. Now the last one, we're reading through it. Okay, we see the important tips telling us that V is equal to 0. It means that it's stopped. There's no motion at all. So the last thing we have to do is that the dissipated energy has gone to the table and to the ball. So there's no motion. We don't have any kinetic energy. The only thing that we have left is dissipated energy. Okay, so this one should be all in 100% dissipated energy. Okay, so what you're going to do now is you're going to make comparisons to this drawings here, to yours, and make some corrections, make some adjustments to what you thought about, and explain the reason why you had your previous answers and what certain things you learned from here.